random question here. 7.689 moles of sodium chloride. 7.689. All right. My question to you will be, how many sodium ions are in 7.689 moles of sodium chloride? Okay, how many sodium ions? What letter is associated with the 7.689? You've got three. Na, N, or little n? Little n. What is the substance that we have that many moles of? What's the substance? Sodium ions or sodium chloride? Sodium chloride. So, when we write out Avogadro's number, it has to be for sodium chloride. Whatever you're given the moles of, that is the particle that goes in Avogadro's number. So big N, A, is 6.02 times 10 to the 23. What do we call the particles for sodium chloride? Formula units, yeah. All right. So we have now.
Is it always over 1 mole?
Always. We have Avogadro's number, we have the number of moles. It wants how many sodiums. So we are essentially looking at a how many question. How many? We're looking for big N. So 7.689 oops. All right. Now, when you seems very bright in here. Okay, that's better. Okay. When you have a quantity, a unit on the top and the same unit on the bottom, they will cancel. So we can get rid of our moles. So what is 7.689 times 6.02 times 10 to the 23rd? Alexandra.
Exactly, it's 4.628778 times 10 to the power of 24.
Okay, let me get this. Can I just read back what I think I heard you say?
Yeah.
What I think I heard you say. 4.6287.
78.
Not 87, 78?
No, just after the 87. You got the first part right.
Okay, and times 10 to the,
Power of 24.
oh, see, I wrote down 28.
Okay, wait, so 4.62.
I don't know if I can erase it now. Can I erase it now? Nope. Okay. 7, 8. All right. Times 10 to the 24 formula units of NaCl. So I've got the number, but the units are not correct. I've got formula units of sodium chloride. but I don't want sodium chloride, I want just sodium. What are you going to multiply this by? Marco,
1,
why?
because there's only one sodium
Ion
ion
in? There's only one sodium ion in
and sodium.
NaCl, yeah. So, to get rid of this unit, formula unit, I need my formula unit to go on the bottom. And I need my number of sodium ions to go on top. There's one sodium ion for every one formula unit, like Marco just said. Bless you. Formula units are going to cancel. One's on top, one's on the bottom. So we will have 4 point. Now, how many significant digits? Here.
4.
4. Avogadro's number is a given quantity, so we don't count that as having significant digits. So we're going to have 4 in our final answer. If we had chosen to use more of Avogadro's digits, we could then change that. But for now, we're just going to say don't use Avogadro's number for significant digits. So we've got a lot of sodium ions. But it happens to be the same number of formula units. Okay? Yes. Atomic mass units. And the symbol for this is a U. Sometimes textbooks use AMU, but we will use U, the letter U. So one atom of carbon-12 has a mass of 12.00 atomic mass units. What would be the mass of a carbon-13? Yeah, 13.00 U. 1 mole of carbon-12, 6 times 10 to the 23 atoms, so a lot more atoms. So 1 mole has a mass of 12.00 grams. That's for 1 mole. So the number that you have on your periodic table for the mass is the same number, different unit, depending on whether you're talking about a mole of something or an actual atom of something. So 1 mole of an element has a mass in grams, while the other numerical value is the mass of 1 atom in U. But they're very different quantities. One is 6 times 10 to the 23 atoms. The other is just 1 atom. So the mass of 1 mole of substance is called the molar mass. The symbol is a capital M, and the units are going to be grams per mole. So in the periodic table, the units for your masses are going to be grams per mole, because we're either talking about a mole of atoms, or it's going to be U for 1 atom. So Angela, pick an element. Magnesium. What is the mass of one atom of magnesium?
24.008.
No. What's the mass in the periodic table?
24.31.
24.31 U. What is the mass of 1 mole of magnesium atoms? 24.31 grams for every 1 mole. So that's per atom, and that's per mole. And you put on the unit grams per mole. So every mole of water molecules has a mass of 18.02 grams. That's something we can measure, right? So if I take Taya's water bottle and I mass it, we would actually be able to calculate how many moles of water are in her water bottle, because we would know the mass and the molar mass. And then if she drank some, we could figure out how much she drank by the difference left. And then we could figure out how many moles of water she just swallowed. Carbon dioxide, how many carbons?
1.
So 12.01. How many oxygens?
2.
What's 2 times 16?
32.
Don't forget your zeros. All of the molar masses on the periodic table that I gave you have 2 decimal places. So you should always have 2 decimal places in your molar masses. So the molar mass of carbon dioxide is 44.01 grams per mole. So if I have 1 mole of water and I have 1 mole of carbon dioxide, which one's heavier? Carbon dioxide. Seems a little weird, doesn't it? That a gas that you can't see is heavier than the water that you can see. Okay? So in 1 mole, there's more mass in this compound than there is in that compound. All right. Sodium chloride. What's the molar mass of sodium?
22.99.
What's the molar mass of chlorine?
35.1.
Add them up. Put on grams per mole.
Is that it?
That's it, that's it. That's how you calculate molar masses. That's how you calculate the mass of 1 mole of any substance. If it was just an element, if it was just iron, it would just be the number in the periodic table followed by grams per mole. So 55.85 grams per mole. All right. Now, the amount of a substance, the mass, and the molar mass are related to each other through the following equation. The number of moles is equal to the mass divided by the molar mass. Mass divided by molar mass. So, big M, molar mass, you have to start putting in your units. Moles Small m is mass. Grams. So we're going to do a couple of examples, and then I'm going to give you some questions to do. Mass is 40. We have to figure out the molar mass, but we can. And we're looking for moles. So a typical question will say to you, either this is the number of moles, what's the mass? Or this is the mass, what's the moles? But they don't tell you the molar mass. But they either give you the name or the formula for your compound. You have either one of those, you have a periodic table, you can find your molar mass. So we've got 12 carbons, 22 hydrogens, and 11 oxygens. So what is 12 times the molar mass of carbon? Twelve times 12.01. Beautiful. What is 22 times the molar mass of hydrogen? And what is 11 times 16? Don't forget to put in the zeros because you should have 2 decimal places. Your calculator will drop them. So you add all of these up and you have your molar mass for sucrose. Hopefully you got the same answer, 342.34. Okay. Now that you've got the molar mass, you can now calculate your answer. So 40 grams divided by 342.34 grams per mole.
I get unlimited numbers.
What do you mean unlimited?
I get 0.11684.
And it'll keep going. Yeah.
So you have 0 moles.
No, we have less than 1 mole,
Oh, okay.
right? You'll have a small number. You have a small number because 40 is divided by a bigger number. So it will be less than 1.
So we do it 1.
We're gonna figure it out, okay? All right, so give me the answer your calculator gives you slowly.
0.116842904.
Okay. You would not have to write out all of those numbers. When you record a number for me, before you round it off, carry at least 1 extra significant digit than you need in your final answer. So let's go back up to our initial data. How many significant digits in 40.0?
3.
3. There's trailing zeros and a decimal, so they both count. How many significant digits in your molar mass? 5. So you can only have 3 significant digits in your final answer. So we're going to keep that position. So we're dropping the 8, so it rounds to 7. So 0.117 moles of sucrose. Which itself doesn't seem like a lot, right? That doesn't seem like a lot. But you know what 40 grams looks like. 40 grams of sugar is a lot. It's quite a lot of sugar. So, yeah.
When when you round it, when you look at the one with the more significant,
No, you want to look at the one with least number of significant digits. All right. So we need 6 carbons, 12 hydrogens, and 6 oxygens. So 6 times 12.01. I think I did this right. Get the same number?
Yeah.
Beautiful. All right. Now we know the molar mass. Okay, so that must mean we're given the number of moles. We sort of are. We're told that we have 4 millimoles. You have to convert that to moles before you do your calculation because you have to have the same unit. You have to have moles in your n value to cancel out the moles in the molar mass. So do you know which one's bigger, a meter or a millimeter? Meter's bigger. Do you know how many times bigger?
1,000.
It's 1,000 times bigger. Milliliter to a liter, millimoles to a mole, milligrams to a gram, millimeter to a meter. They're all different by 1,000. So there's 1,000 millimole in every 1 mole. That is called a ratio. It's a ratio. It's a mathematical relationship. I could also write that 1 mole contains 1,000 millimole. These quantities, these ratios mean the same thing. They show a relationship between 2 different quantities. Now, I want to get rid of millimoles and I want to keep moles. So in order for millimole to cancel, it has to be on the bottom when I use my conversion ratio. Which one of these 2, here's 1, here's the other, which one of these has millimoles on the bottom? Top or the bottom one? Bottom one. So I'm going to use that ratio. So I'm going to take my 4 millimoles and I'm going to multiply by 1 mole over 1,000 millimole. Now my millimoles cancel. I'm left with moles. So you take your 4.0, divide by 1,000. Yeah.
4 times 10 to the power of -3.
So you could write 4.0 times 10 to the -3, or you can write it out with decimals. 0.0040 moles. They're the same quantity. So it's up to you how you write them. All right. Now we can figure out mass. What's our formula going to be? Yeah.
N times N.
Yeah. It's going to be N moles times the molar mass. Did anybody else get that answer?
You.
Did your calculator give you exactly 0.72?
No.
What did your calculator give you?
0.72. No, like right after 72, it's
0.72.
0.7. Oh. Like that?
Yeah.
Okay, that's just freaky. It's just freaky. Look at the symmetry and some numbers we're getting up here. Up there. Down here. All right. So we can have only 2 significant digits in our final answer. What are our units? Grams. Because our moles cancel, we're left with G, grams. You must put in your units in these questions. If you get the wrong units, like if you get grams over moles squared, you know you did the wrong math. Okay, so use your units. So you guys can start working on the questions on the back. Well done.